Thank you for coming along. It's the last, I'm sure, of a long day for you all, so thanks very much for coming down, and thanks very much for finding this place, because I couldn't find it for about 10 minutes. I was getting a bit worried where I was going to be. So, hopefully you're in the right place. This is going to be about JCache, JSR107. So that's a new Java standard around caching data in Java. My name's David Brimley. I'm a senior solutions architect. I work for Hazelcast, and Hazelcast are a memory data grid provider. We're an open source company, and one of the things we do is we implement JSR107 along with many other vendors. My background is in memory data grid, so I've worked with other products like Coherence and Gemfire, so I'm guessing some of you have as well. I run the Hazelcast user group in London. So come along and join that. And yeah, I've been messing around with computers for longer than I care to remember, actually. I was upstairs. Has anyone been upstairs to that wall, the wall up on where you put your picture up with 97, all the dates on there. So I was right at the end, so I was feeling really old. So the talk is about 40 minutes long. There's lots and lots of code samples in it, so hopefully you'll like watching people running code and looking at IDEs on big screens, because that's really what the majority of the talk is about. There's a few slides, really, but you'll just be listening to me talk an awful lot. So first of all, kind of an obvious thing, but we'll be talking about why you would want to use caching. And then we'll give you an introduction to JCache. I'll just briefly go over its history and tell you about where you can find the specs and things like that. And then we'll actually get into the real meat of JCache. And from here downwards, really, it's just an awful lot of code samples, and we'll run some stuff, and we'll try and plug and play with some vendors. So we'll talk about the caches and some of the other features. And I'll be taking gulps of water along the way because my voice is dry. My voice is giving up on me. So, quick show of hands. Is anyone using a cache or any memory data grid or anything like that at the moment? Okay, that's not that many actually, quite surprising. So, presumably you're all here because you're thinking about using something like that. So that's good. So the people that put their hands up, you're using things like Coherence or Hazelcast or whatever. Yeah, cool. So, kind of an obvious thing. So I'm sorry if I'm teaching you old stuff here. Why do you cache? So, many years ago we all wrote client-server systems, didn't we? Where we had a piece of client code that connected directly to a database, and we rolled that out to our business users, and it all worked wonderfully. And then we added more and more users and more data, and things slowed down. So then I'm sure all of us have done this in the past. We started to cache some data in our applications, just a naive data structure we put it in. And of course, we all found out that if we start caching things in memory, then obviously our responses to our users are an awful lot faster. So this kind of gives you a point of reference that we start going down here from disks. And admittedly, these are all in nanoseconds, but, that's a millennium in distributed system times. And especially if you're dealing with, hundreds of thousands of operations a second. Sorry, I'm blocking you over there. So you can see down here we start with disk, round-tripping in data center. Generally within a data center, if you're round-tripping, you're doing about half a millisecond. You're reading from a random 4K SSD. You're doing that in 0.15. And you can see as you go further and further and further up, if you actually get down into the L1 cache, really, really fast. And then if you get down into the main memories, then it's still faster still. So in memory, if we can store all of our data for our application in memory, you're going to get really, really fast speeds. Okay, so that's why we talk about caching in memory. And of course, the cost as well, right? Memory is really cheap now, so we can afford to have servers with terabytes and terabytes of data on them now. Okay, so in terms of the the application of this, you can use it, as I said. Slow database was the problem we spoke about earlier. You've got persistence frameworks, HTTP proxies, and for that you would use local caching, data grids, document stores, second level caches. Caches exist in all sorts of parts of our software, okay? And what we deal with them, how we deal with them. So, JCache. As I said, it's a caching specification for the Java platform. So when somebody asks me to describe it to them in one sentence, if any of you were around, maybe, I don't know how long ago now, but when we had Java and we didn't have JDBC, or when you've had any of these programming languages and you haven't had a common API to deal with all of the different databases, you would have known how hard that is. And today, if you want to deal with a cache, as I said, you can write your own. You can maybe use Google Guava Cache, and there's some other caches. They're all single-process caches. Then you've got the distributed caches like Hazelcast, Oracle Coherence, those types of guys. But the problem with that is you've kind of got vendor lock-in. All of their APIs are very, very different. They deal and solve similar problems, and they have similar feature sets. But if you use Oracle Coherence and you've got many, many systems, you're kind of pretty badly locked in there. So this is why JCache came along. I think I'm right in saying that it's the longest ever running JSR. It ran for, I think, about 10 years. It started off and then it kind of died a bit, and eventually, I think about 2 years ago, Greg Luck and Brian Oliver are the people we need to thank for this. Obviously, a lot of people have done work prior to that, so obviously there's a lot of people involved, but these are the guys that really pulled it over the finish line. So Greg Luck is actually CEO of Hazelcast, so he's my boss. And Brian Oliver is a gentleman who works for Oracle Coherence, very well-known chap. So, as I said, it's a long time coming, but it's eventually here. It was actually came out in March of last year. So we've had a year of JCache. So in terms of what it solves, when you're caching, generally the data structure, one of the data structures you'd use is, it's a key. You'd want to try and use a key value store, okay? So with Java, you've got the map. And as I said, you could implement your own naive cache. It would be single process. And there's the features that you get in the map. Now, there was a deliberate choice they made. They didn't just say that, we're going to work with a map. They've come up with a structure that resembles a map. It's actually a Java X cache. Okay, so they're both key value based. They both support atomic updates. But if you think about it, when you're dealing with caching, one of the things you want to do is you want to have entries expiring out of the cache, right? You don't want to keep pushing stuff into the cache and eventually your memory blows up. So entries can expire, entries can be evicted, okay? The other important thing as well is entries can be stored anywhere. So the JCache specification doesn't deal with how distributed systems should handle the cache, okay? If you look at the TCK, and we'll look at that briefly in a moment, the reference implementation, which by the way don't use that in production, is a single process. Is a single process implementation. So JCache and JSR107 doesn't express the distributed system that lies beneath the cache. Okay. So the other thing as well is you've got store by reference with a regular map. In Java caching, you can do store by value and store by reference. And then you can see there's a bunch of extra things you get at the bottom. So it supports integration. And by integration, I mean you can link your cache to some kind of data store beneath the cache. Okay, and we'll look at that in a moment. And by data store, it's generally a database. but it can be something else. It's not mandated, it's just an interface, and you'll see how we use that. The other thing is observation. So we can start to register callbacks and listeners against the cache, and we can get callbacks and be informed when things happen inside the cache. Okay? And then finally, there's statistics, and then there's entry processors. Now, entry processors are a really nice structure that allows us to query and mutate the data actually at the data's location. So less useful in a single process cache, but when you're using JCache with a distributed cache vendor like Hazelcast, entry processors will allow you to send functions out into the cache, out into the distributed system, work on the data and return results back to you. Okay. So as I said a bit earlier, JCache makes no assumptions about topology. Okay, so there's nothing in the spec, there's nothing in the configuration of JCache that says this is a distributed system, it runs on this many nodes, or it's a single process. It doesn't deal with any of that. You would configure all of that beneath the covers with whatever vendor you were using. Okay, all you need to know is that JCache is a common API that you can use to program against the data structures that are provided by the vendor beneath. Okay. So, how are we doing? First 9 minutes. So here's all the borrowing stuff, the JCP links, and there's a forum on there as well, actually. So this is the place that the spec leads watch. It's still, JSR107 is still a living thing. The forum's still active. There's conversations going on there about what's going to come in the next iteration of JSR107. So there's talk about extra features. And you can go and download the tech specifications from GitHub underneath JSR107. You can get the reference implementation. So if you're a software vendor and you want to adhere to JSR107, you can get the TCK from there, and you can run your software against the TCK and validate that you're JSR107 compliant. But that's not a bad place to start and to look around if you want to learn a bit more. So, I don't know if that's going to work. There he is, there's Mr. T. So at the moment, and these are the TCK compliant vendors. So I know there are some other software vendors that are working towards compliance, and they've got some small JSR107 implementations and tests that are available. So at the moment we've got Oracle Coherence, Hazelcast, JCache, and then you've got Infinispan, which is the Red Hat open source in-memory data grid. So, these are the providers at the moment, and there are more coming along all the time. In fact, actually, I think I've done them a disservice. There's another vendor on here that should go on here. There's a company called GridGain as well. So there are many vendors coming along, but just beware. As I said, there are lots of people that are experimenting with JCache, lots of software vendors. Just make sure that if you are going to go into production, and the main reason you're using JCache is to get that vendor neutrality, is just make sure that they are TCK compliant, because if they're not, and you do decide to switch vendors underneath the covers at some point, you might be in for a nasty surprise. You might not be able to switch. Okay. So, just one other thing. If you are benchmarking against vendors, because this obviously now you've got a vendor neutral API, you can write your JCache puts and gets to caches, and you can hopefully just plug in different vendors and do some benchmarking. If selecting the fastest cache is your thing, then JSR107 makes it very easy. But just don't do that against a single instance, obviously. You're better off if you do benchmarking against a real use case. So, enough of that boring stuff. Let's talk about the code. So to get actually up and running with JSR107, there's a nice Maven dependency up on Maven Central. So you just go ahead and grab that. Plug it into your project. You can do Gradle and all. There's all the other things you can grab it by, and then you have that, and then you just download your vendor-specific jar as well. So there's the Hazelcast jar you can use, and it's embedded within Hazelcast. If you use Oracle Coherence, there's an extra jar I think you need to download. So all of the vendors will have a jar that will be their JCache jar as well. So you have that, and you have your vendor jar or Maven dependency, and you should find that if you code to the JSR107 API, you can just switch around with your vendors. So at a very high level, this is basically the classes that you would go through down to get to, ultimately to your cache object that you want to use. So the caching and the caching provider. So the caching provider is actually, that's where the vendor will implement against. Okay, so each vendor will have a caching provider. And it's caching up here is how you would get your reference to the caching provider. That gives you a cache manager, and from the cache manager you can create caches and retrieve caches. Okay, so it's a fairly simple API to get to use. So let's do a demo. And if I flick over here, we'll look quickly at this demo here. Now, let me just come out of this view here, because I want to show you my POM file. I've got a little project here with all of my demos on it. And if I show you the POM file, that's a bit hazy there, isn't it? Let's put that into presentation mode. There's my JavaX cache, okay? And now I've actually, in this project, I've got Hazelcast, I've got cache, and I've also got Oracle Coherence down there, okay? So I've got them all on my class path. And then if we go back to my small bit of code here, which is the provider, you can see here that I'm I'm saying to caching, get me a caching provider. It's giving me the caching provider back, and then I'm getting a cache manager. It's off the cache manager that I can start creating caches. So there's not an awful lot of code there. Now, this is going to fall over when I run this. And it's going to fall over because, as I've shown you, I've got 1, 2, or 3 different caching providers on my class path. Okay, generally you wouldn't really have that, right? But just something to be aware of. If you've got lots of different vendors on your class path, if you just do the generic get caching provider, it's going to fall over. It will complain that there's not just one on the class path. Okay, so what you would generally do, just to be safe, is in this caching provider, you can provide it with kind of a key, and each vendor has a key to say, this is my caching provider. So you can see here I've got cache, I've got Hazelcast, and I've got Coherence there. So if I were to run that, it would just start up a caching provider. So what we'll do though is I won't run that, but what we will do is let's actually look at a real example of using a cache. So here we go a bit further, and we're getting our caching provider, and this time we're using that, that key of Hazelcast, and we're bringing back our manager. And now what we're doing is we're actually configuring a cache. Now, JCache, you've got two options when you configure caches. Okay, you can underneath the covers still use the vendor's configuration, so there might be a vendor XML or something like that you can start to configure your maps and caches, or which is kind of dangerous, or you can use this mutable configuration. So this is the JCache way of configuring caches. Okay, you can see it supports generics as well, so we can give it types, and you can see here I'm creating a cache config, and I'm saying store by value is true, and I'm just setting some types. So that's about as simple as it can get in terms of configuring a cache. And then I'm saying to my manager that I've got here, create me a cache. I want you to call it capitals, and give it this cache configuration and return the cache API. And now you can see I'm just putting in some some data in there, and then I'm doing a query. Okay. So if we were to run that now, because what I want to show you is this running with one provider, and then we'll switch to another. So it's running with Hazelcast now. So if we run this, so Hazelcast by default, and same with Coherence and a lot of providers, it uses multicast to try and discover clusters. So there you can see that, you don't know if you can see that very well, but what that's saying at the bottom is it's just done a get, and it's got out that Brussels value where this code here. So we've put our entries into the cache, and we're getting the capital of Belgium. Okay. And one other thing as well. So that was with Hazelcast. So let's now switch that. So we use Coherence. And when you watch the logs, if you can read it from where you are, you can see now we're using Coherence. Okay. Oh, that wasn't meant to happen. Sorry. That's not Coherence's fault. That's my fault. Don't blame them. I've got this here, and I'm going to talk to you about this in a second. Let's run again. So here we go. Coherence is starting up, and there you can see the capital of Belgium. So exactly the same code is running with two completely different software vendors. Okay. So let's take a look at that bit of code that caused us to fall over there. Now, as I said, you're really going to want to stick as much as possible with the JCache API to give yourself that portability. If for whatever reason, though, you want to get hold of the underlying vendor's interface to the cache, you can do that, okay? Because although the vendor will be giving you the JSR107 API, a lot of vendors, the data structure that it's ultimately stored in has many other features. So one of them generally being things like asynchronous puts. So that's something that the JCache specification doesn't give you at the moment. So the way you can do that, the way you can get to the vendor's interface of that data structure is by using this unwrap method here. So what I'm actually doing here is I'm saying cache unwrap iCache class. Okay, and I'm getting the iCache back. And iCache is the Hazelcast interface for an iCache. If you're doing this with something like Oracle Coherence, you would unwrap to something called a named cache. Okay, so if you want to live a bit dangerously and really negate the whole point of JSR107, you can get back to the vendor's native API if you want to. So let's go back to the slides, and we'll play again. Now, entry processors. Now, this is quite a nice thing. As I've said, if you're a single process, this doesn't really make an awful lot of sense. But if underneath the covers you've got a big distributed cache and it's running across many machines, you've got gigabytes or terabytes of data, and you want to start computing on that data, like this, generally there are two ways you could do that. Okay, you could have your client application or your application inside the cache do gets. So you're doing lots and lots of gets from different data structures. You're bringing your data back. You're working on it in some way, and you're putting back the results, which would kind of be this type of flow. And you can see right there we're in a distributed system, so this could potentially be network hops. Okay, so that's a lot of network hops going on, and that's going to slow you down to do your business calculation. Or you could do something called an entry processor, which runs out in the grid. You say, the entry processor effectively is a way of running a function over data entries in your cache. And it can return you an optional result object if you want. So you can see right away that the actual number of network hops involved in doing that are much more efficient. Your you're actually updating or working with the data in the grid where it lives. You're not grabbing back the data to where you want to do the computation. So it's very, very, very efficient. And also one of the nice things about this is you don't need to do any kind of locking. Because you're updating that data in situ, and because the threads that deal with that generally are the same threads that deal with the puts for that data, you get this lock-free benefit. So if you imagine when you was doing that with map gets, so you're all the cluster, and I'm the application, and I'm getting my data back from all of you, all from these different nodes. I now have the data. If I want to work on that, I need to lock all that data to stop someone else updating it. Okay, so because I'm updating it in situ, I don't need to do that. The one other thing you need to be aware of is because underneath the covers we're dealing with distributed data, the objects that you store need to be serializable. Okay, so you need to implement a serializable interface on them. So we can do a quick demo of that. We've got 25 minutes left. What I'm going to try and do is I'm going to try and finish the talk in about 40 minutes, and then we can do some questions at the end. So let's look at this multi-update example to begin with, and this is what I was describing as kind of the naive way of working with the data. We've got our JCache data here that we saw earlier, where we're creating some capitals, and then you can see we've got this iterator, and we're grabbing data and we're iterating through it, and we're actually uppercasing the values. Okay, but that's involving lots and lots of network hops. So I'm grabbing all of the data, mutating it, sending it back into the cache. Okay, so that would be the naive way of dealing with this problem. Okay, so we're iterating through the data. So you can see that JCache gives you this iterator, and then you can actually loop through, and this is actually doing network hops as it loops through. Okay, so I'm getting the cache entry, the value, and I'm just doing this string to uppercase and replacing it back in the cache. Okay, now I should talk about replace. This is a nice compare and set operation. So this is kind of an optimistic update, if you like. Okay. So what this is doing is I've got the value, which is my old value, and uppercase is my new value, and that's doing an optimistic update into the cache. So if, whilst I've been doing my operation, someone else on the same key has changed the value, when I come to do my replace, obviously that value is going to be different, so it will throw an exception for you. So it's a nice way of, you don't have to do, well, you don't have pessimistic locks in any case in JCache, but this is a nice way of doing it. So it's optimistic locking, optimistic replace. Okay, so what we'll do is now let's look at the entry processor. The much nicer way of doing this. So here, you can see right away a lot less code. Okay, there's our regular code there at the top where we do our setup. And what we're doing here is, off of the cache interface, there's this invoke method. There's also invoke all. Okay, so what invoke is doing is I'm giving it a key. Okay, so I'm saying wherever the record of Belgium lives, okay, I want you to run that entry processor on it. So this is the entry processor, and you can see all I'm doing is I'm just checking to see if it exists to begin with, but then I'm just setting it to uppercase, so I get given the entry, okay, and then that's the reference to the object in the cache. So what's actually happening is I'm a client, I'm running an entry processor, okay. The cache knows that Belgium, you're part of the grid, the cache knows that the Belgium record is on you. The entry processor is going to you. We're calling your stack, your process is calling the entry processor, passing the Belgium record, and we're mutating it and setting it back into the cache. Okay? And that's all being done on you, okay? Here as well is where you can return that optional result. So you can be doing some processing on lots and lots of different keys, and this can be some kind of aggregate or some other kind of result that you can return, but I'm just returning null from here. But that can be an independent result object that you return, okay? So if we were to run that now, and again, let's come out of here. And so I'm using the JCache caching provider, and so we'll update the Belgian record. So actually, one thing I should mention is it's not very easy to see, but you can recognise the code. That is invoking against one particular key. Okay, so you can pass it many keys, or you can also what you can say is there's off of cache there's invoke all, and that will just run against everything in the cache. Okay, so if you want to do a mass update of all of the records in a cache, you can just do invoke all, and bam, that entry process will run out everywhere for you. Okay, but this one we're just saying I want you to find out and run it on the node where Belgium lives. So let's get the right one, and you can see here I'm using JCache here. And it's just doing its little multicast check around the network to see if there's any other nodes to join. And there you go, bam, it's done. And you can see it's uppercased. So we ran the code, and and that entry process should have uppercased the value. So you can see there originally we had the lowercase Brussels, and then we invoked the entry processor to set it to uppercase, and then we did a get from the cache for Belgium again, and there you can see there's the uppercase. Okay, so that's a very contrived example of an entry processor. So, how are we doing? 20 minutes. I've got to speed along now. The other thing that's really nice is listeners, okay? So, if you imagine there's lots and lots of updates, maybe some kind of trading system or some booking system or anything you like, there's updates going into the cache. So there's many, many different business applications updating the data in the cache, doing cache puts. You can have other applications that listen to those updates, okay? And you can listen with filters as well. So if I'm an application and I want to listen into the cache, any updates for any entries that hit some kind of criteria that you specify, okay? So a simple observer pattern, you get the types of operation events that you would expect, like create, updated, removed, expired. And you can pass back iterations of events as well if you want. You don't have to pass back just individual iterations, okay? So the easiest way of showing this, again, is another quick code sample. And we'll go over to here. Where are we? CacheEntryListener. Right, brilliant. So what we have in here, let's kill these guys as well. What we have in here, again, it's the same code that you've seen before, but we're just registering. Let's go into presentation mode. You'll be able to see this better. So we're setting up our configuration. We're getting our cache of capitals, and I'm creating a listener. Okay, this is a bit longer. I should have maybe nudged that down a bit, but we're creating this mutable cache entry listener configuration, and then we're registering the listener on the cache, okay? So what this is doing, this is basically saying, I want you to register this cache entry listener class against this cache. And there's some other things over here that will, there's other settings over at the end, the falses and the trues. They'll be dealing with things like, do you want values to come back with the listener as well? So you can just get ticks without values if you want to. You can just be informed that something's been updated without passing the value over. So what this will do is, and then you can see I've registered my listener, and then we're going to do a whole bunch of puts into the cache, okay? So if I run that now, I'll just come out of here, and we run this. What you would expect to see, of course, it's just a regular listener. Oh, let's pump this up. And I need to show you the listener code as well. But what this will do is there's no kind of filtering on this. We've not put any filtering. It's just a vanilla listener. And you can see there's all of the created methods at the bottom there. So it says I've created UK with value of London, created France with value of Paris. Okay, so every single put we've put in there, it's come out in the listener. And if I show you that listener code, you can see here very simple stuff. It's basically just implementing this cache created entry listener, and you can see that for the iteration of events I've got, I'm just doing a system out.
Could you go into the presentation mode, please?
Yeah, sorry, it's a bit hazy there, isn't it? There we go. That's better. So the other nice thing about this listener interface is that you can build up the events you want to listen to. If you've ever dealt with any other observer or listener types of interfaces, you'd have implemented the listener, and bam, you've got about 8 methods or 9 methods that you need to, well, you don't implement, but they live there generally, and you find you're just not using half of them. So what you can do in here is you can actually just use the ones you want to do. So you can see I've implemented cache entry created listener and cache entry updated listener. Okay, and we get the iteration of events as they come through, and we're just publishing them on the system out. Now, let's do one with a filter. Obviously, that was just showing us everything that occurred on the cache, but we might want to use a filter and only get triggered events that give us a filter. So it's a pretty basic type of predicate operation going on here. So for every potential result that comes, evaluate gets called, and it gives us the actual cache entry event. And you can see here I'm doing something very simple. I'm just saying I want to only return true if the value is London. Okay. So if we run that code again, and I'll go back to the actual listener. Here it is. And what I'm going to do is I'm going to block out that one there. And I'll put this into presentation mode in a second. I'll uncomment that one. And now what I'm doing here is I'm registering, this listener I'm registering here is using that filter. Okay? So now, when we run the same code, let's actually put that on there. When we run the same code, it should only show us the London tick. Oh, that's nice, isn't it? I didn't know that would work like that. Ooh. You see, that's formed a cluster of 2 now, actually, because I had the second one running. There you go. And there's London now, popped up at the bottom. You won't be able to see that there. You have to trust me. You trust me? Good. So there's London, okay? So that's the way you can do filtering. So obviously in your filter, it's going to be something a bit more complex than that, but that gives you a nice idea of how you'd use filters, okay? We've got 14 minutes left. So quickly go back to our presentation. So we spoke earlier as well about connecting up our cache to some kind of underlying store, okay? So that, as I said, generally a database, but it doesn't have to be a database, okay? So if you imagine that you're doing puts into a cache or gets from a cache, we have something called cache loaders and cache writers. And you can connect cache loaders and cache writers to your cache, and what will happen is, if I do a cache get, and it goes out somewhere in the cluster, and it doesn't have to be a cluster, but I do a cache get, that key doesn't exist in the cache, in the in-memory cache. What it will do is it will call the cache loader, and it will call the interface, the implementation that you provided, will give you the key, and depending on what, whether you've got a relational database or it's another system with a REST API call, or it might be a file system, you can write the code that gets that value. You return it back up out of that interface, and it gets placed into the cache. So you can do a get, and it'll be completely transparent to the user where that data ultimately is coming from. Okay. Same with writers. If you do a cache put, you implement a writer against that. That writer can be an insert to a database, or again, it can be a REST API call, saving data somewhere. That will be called transparently to the put. Okay. This is kind of what we've described there. So you've got the application, goes to the cache, and then it can go to the backing store, and that backing store can be anything. Okay. So demos are the best way of describing this. So let's look at the cache loader example. So the cache loader, Again, our familiar code we have here. But the thing to notice is the mutable configuration. We're setting the store by values and the types and everything else, but we're also setting these values here. We're setting a loader factory, which we're calling my cache loader, and we're also saying read through. So what we mean by read through is that process of doing a map get. We find that it doesn't exist in the cache, so we do a read through to the backing store and call this my cache loader class, okay? So that my cache loader class is this chap here. We implement the cache loader, and you can see it's got the key and the value generic. And so when the map get occurs, the value is not in the cache. The implementation should call load, and it will give you the key, okay? And generally, you'd write in some database code, or you'd have a DAO layer here that you would connect to. In our small example, we're just saying we're simulating if someone asks for Portugal, we'll return up Lisbon as the capital, okay? So if we go back, and what you'll see is, where's the loader? Here we go. What you'll see is here we don't actually load Lisbon into our initial data set, but what we're going to do a get, and we're going to get for Portugal. So that will call that cache loader. So if I were to run that now, you'll see that, and we're going to run this with coherence this time. Let's hope it runs. Oh, sorry, I'll run the listener there. Let's kill these as well, because we're running coherence on the same. So we run that. So you can see then now, we're using JCache. You've got entry processors, you have listeners, and you can also connect up your caches to any kind of underlying data store. So here's coherence firing up, and right there at the bottom, you can see it's pulled back Lisbon. So it's gone down, it's gone into that cache loader, and it's grabbed the value up, and that value now lives in the cache, okay? And that value will live there for as long as you want it to. You would have to set some kind of expiry policy on the cache to expire, okay? So that's the loaders, and we've got 9 minutes left. I want to try and get through to the end of this so we can do some questions. So there's loaders. Obviously, there's a cache writer as well. I didn't show you cache writers, but it's a similar concept. You can actually write through to some kind of database or underlying store. There are annotations as well that are supported in Spring Juice and CDI. So you can put annotations onto your methods that will return cache results or will do cache puts and removes. So you can use annotations as well with JCache. I won't do that, but I'll just go through what we, I say missing bits, but these, as I said, JSR107 is a living thing at the moment. They're talking about new features. Potentially, I think the most likely one, if it does come along, will be an asynchronous API. So when you do cache puts at the moment, it blocks until the provider says, I've stored the value for you. But there might be a potential of something like an asynchronous API coming along. You've noticed, well, there's no real way of doing kind of queries, like property-based queries. So something along the lines of saying, return me these values where a property of the value object equals X. We don't have anything like that really in queries. You could conceivably do that with an entry processor, though. So if you think about it, you could do an invocable entry processor that would run out on all of the nodes, and you could evaluate each record as you go with your properties. It's kind of a full scan way of doing it, but nonetheless you could do it if you wanted to. It wouldn't be quite as efficient as doing a real query, though. And finally, I believe it's going to be in the JE8 spec as well. And there's potential Java 8 lang features as well. Okay, so we've got 8 minutes. Is there any questions from the audience? I'm sorry, I did download the app, but it kept crashing my phone, so I don't know if anyone's using that app. But if they are, you're going to have to ask me the question.
You mentioned multicast.
Yes. Yes.
Are there mechanisms you can set up?
Yes. Yeah. As I said, JCache doesn't really mandate anything to do with the distributed nature of things. It can be a single Java process if you want. Indeed, the TCK reference implementation is a single process. But going back to your question. If you wanted to do that, it depends on your vendor, is the first part of the answer. But speaking about Hazelcast, what you can do is you can use the Hazelcast configuration. You would need to use Hazelcast configuration XML on the class path anyway. And you would, I can show you in fact, you can define multicast, which is default for Hazelcast, and I think it's default for coherence as well. Or there are other options like you can specify TCP IP addresses, and coherence and Hazelcast have service discovery APIs that you can, or interfaces that you can start to use as well. So there are a number of ways, but that kind of distributed system discovery, that's vendor specific. But it will still read the configuration APIs that are on the class path. Each vendor will use its own. Yeah. Any other questions? Hi.
How can I see how much memory the cache is actually using?
Yes. So one thing we didn't touch on is statistics. Now there is a statistics API that you can use to pull information like that, but we didn't have time to go through that. But if you look at the JCache spec, you'll see that there's a stats API that you can do that. You can see things like memory consumption.
Does that include switching it like on and off? Because stats can be expensive.
Yeah, you can switch stats on and off. So as you said, it can be expensive, but yeah, it's available to you there.
Is there the support to JMX as well? Or is there already something that, like, to turn on or off the system?
Yeah, yeah, you can. I believe you can actually. I mean, let's have a look. Actually, I haven't tried it. I'm not sure if I tried it with JMX. Let's learn together. So if we go to the, here we go. Here's the JSR107. Here's the spec. Now this is going to be interesting. So if I might not be able to do this. I'm going to make myself look like a fool. Here we go. There's the specs on the Google Doc. I'm intrigued by that actually. Whilst that's coming up, should we do some more questions? Is there any questions?
About the data store.
Mm-hmm.
What's in the GSR about the replication to the data store, the mode in which it is made?
Mm-hmm. Yeah, so you're talking about asynchronous, yes, to the data store. So yeah, you can. It's kind of vendor specific. But you can do synchronous and asynchronous data stores if you want. So something like Hazelcast can do that, and so can coherence. But you can. We'd need to look at that actually. So if you look at the cache store, I haven't got the Java docs unfortunately, but the way you would do that is, where's the example? It was here, wasn't it? Cache writer. So we're setting the cache writer factory. Let's go offline and look at that configuration. But there are ways of doing that. Can we come back to yours as well? If you've got time, we can look at it after.
I have another thing.
Yeah.
Does it really matter to whether you want to? Does it have to be support asynchronous stuff on the interface itself, or do you just maybe not want to have that in the configuration of the cache?
So asynchronous as of.
You want to put something asynchronously in
Yeah.
the cache.
Yeah.
Does it really have to be on the interface, or is that just a very specific configuration of that specific?
So the JCache specification as it stands doesn't allow for asynchronous puts into the cache.
Just at all?
It doesn't at all. It's a potential future API change.
So things like expiry and eviction, are they like vendor-specific things that you pass in as properties? So if I want to expire after writing, say after 3 hours,
Yeah.
or expiring after access after
Yeah.
1 hour.
So there is a set of standard JCache mandated eviction and expiry APIs that you can use, and you will know that will work with every single vendor. Or if there's a particular specific expiry feature that doesn't exist in the JCache API that exists in the vendor you're using, you can use the unwrap generally, and you might be able to use unwrap and then set an expiry policy. But it does have JCache does have standard expiry, the types of expiries and evictions that you would expect. So
Sizes, things like that,
yeah. So you can do it on sizes, and then the actual eviction policies will be the things like least recently used, that kind of thing.
And the max sizes kind of work across distributed.
Yeah, yeah. As I said, JCache doesn't know that you've got a distributed system. It doesn't care. Yeah. So we've got 2 minutes left. No? We're all done? You're ready to go off home or off to the pub or to the party? There's a party up the road, isn't there, at some point somewhere? All right. Well, we'll take a look at those specs in a second. But thank you very much, everyone. I appreciate you coming down. Thank you.